This is Josh White with JW Math Tutoring. Today's video is going to cover 11 problems from the digital SAT math test from October 2024. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Before I begin going through this October 2024 Digital SAT Math problem set part 3, please keep a couple things in mind. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, if you have any questions or comments or alternate solution methods to any of these problems, please do leave them below. Third, most of these problems are going to be done as free response questions, although on the actual tests themselves, they were probably multiple choice questions. So because I don't have the actual test in front of me, I'm just basically going off whatever students remembered, that took the test in the various Reddit threads. So please keep that in mind, that there may be alternate methods you could use to solve these problems if you had multiple choice answers in front of you. Okay, so with that being said, let's go ahead and get started on the first problem here. We have a right triangle, and we're told that B is the right angle. So just put A up here, C down here. We're also told that the cosine of A is equal to 3/5, and that BC is equal to 290. What is the length of side AB? So there are multiple ways you could do this one. One way that you could do this one is you could go ahead and you could basically say this is 3x and this is 5x. Then you could use Pythagorean theorem and 3x quantity squared plus 290 squared is equal to 5x quantity squared. So it's going to be 9x squared plus, I'm just going to write 290 squared until I actually get the Desmos and work it out. So we subtract this, divide by 16. So basically x is going to be this just the square root of 290 squared over 16. It should be 84,100, I believe. Okay, and then comes out to 72.5. So now you can multiply that by 3 to get the side length for AB. So just take this times 3, 217.5. Okay, so that's our correct answer. This side right here, 217.5. And that's what you could grid in. Technically, let me see here. You could see if we can. You could also do 435 divided by 2 if you want to put as a fraction as well, because that would take up basically 5 spaces, 5 characters, which is what you have room for. All right, so this is one way to solve it. I will show you an alternate way to solve this as well. Would just be to find the measure of angle A. So just do arc cosine of 3/5. I'm going to do it like this, so I define it as an exact value so I can carry it along. Okay, now that's giving me a radian value. Make sure you change to degrees here. Click the wrench icon, switch degrees. Okay. So that's A, 53.13, blah, 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 blah. Not going to write the whole thing out here, but obviously, like I said, I'm going to carry it along. Okay. So now you know the measure of that. The easiest way, the shortest way is 53.13. Subtract that from 90, get the measure of angle C, and then just set up the ratio of, oh, actually, no, sorry. No, we don't even need to do that. Excuse me. Now, we know this angle measure, and we know the side opposite it, so we can just use the tangent ratio. All right, so we're just going to say tan of A, which is the 53.3, is equal to 290 over 2, not 217.5, it's AB that we're trying to solve for. Opposite over adjacent. And then for A, of course, you would fill in the 53.13, but again, I'm going to use the exact value from Desmos. So if you cross multiply this and basically rearrange it, you will get AB equals 290 over tan 53.13, or also tan A. So now when I go back to Desmos, all I have to do is 290 divided by tan, and I can just type A because I defined it right there, and see I get the same answer, 217.5, exact same answer, because I carried over the exact value for the angle itself. Okay, so those are two different ways that you could solve for the side length AB. I mean, again, there's technically even more ways. You could technically find the value of C, and then you could, use the measure of C to solve for it. But that's just an extra step that you don't really need to do. All right, let's talk about the next problem. It deals with some trigonometry as well. So this is a question, it's something involving a ramp along the ground, and you were told its height, which is 23.3 centimeters. And it mentioned something about like the angle here with the ground having to be less than, like to measure the angle, having to be, sorry, tangent, excuse me, of the angle having to be less than 1/12. And so then the question is, what is the minimum length of the base of the ramp? So all you're really doing here is you're just saying, okay, the tangent of theta is equal to opposite over adjacent. The adjacent is basically the base, or the part that's on the, the ground, so to speak. And we know that the tangent of theta is less than or equal to 1/12. So the expression that's equal to is just less than or equal to 1/12. So we can take the 23.3 over x and set that less than or equal to 1/12. So this is the inequality that we're technically solving. So excuse me, you can just basically you can just cross multiply, or if you want to think about multiply 12 on the right, obviously 12 on the left, and then x on the left, x on the right, x's will cancel, 12's will cancel, and you just get, let me look at the exact value here, 2796 less than or equal to x. Or if you want to rearrange this, just the same, x is greater than or equal to 2,796 centimeters. So basically, that's the minimum allowable value for the base of the ramp for x in order to make the tangent of the angle less than or equal to 1/12. So just to go here to Desmos to confirm, basically the tangent of the angle is just equal to the ratio, again, of the opposite over the adjacent. So we get this value right, and if you divide 1/12, notice it's exactly equal to it. 0.08 and then 3 repeating. So this just confirms that we have the correct answer. All right, next up, question number 3. Here we have one dealing with a rectangular prism. We know its volume has a square base. So that means, say, this is x and x, and the height we'll just call h. So we know the volume is 54. Surface area of one non-base face. So that means that means either like the front or the back, the left or the right. One of these kind of 4 upright sides in my picture, not the top, not the bottom. All right, is equal to 18. So those sides the area of them is just going to be x times h. So we know x times h is equal to 18. We just want to find the length, width, and height of the prism. So if you notice here, the volume, of course, for this is going to be x times h, or x squared times h. So at this point, you basically have 2 equations, with 2 unknowns. So if you wanted to, you could just go to Desmos and punch these 2 in. Except we got to use x and y. We can't use x and h. And then we're just going to look for the intersection points. The intersection points are going to be our solutions. So here's one at 3, 6. Do we have any others? Doesn't look like it. I don't see any gray points highlighted. Yeah, it looks like this is the only intersection or solution points. That just tells us that x, which would be the length and the width, because they're the same, is just 6. And then the y in there, which was, excuse me, not 6, 3. Length and width are 3. and then the height, which was the y coordinate from the point, is just going to be 6. And you can just now plug these in and confirm them. 3 times 6 is 18, so that matches the area of a non-base face. And 3 squared is 9, times 6 is 54. That gives us the correct volume of 54. Now, if you want to solve this without using Desmos or not, whatever, do it by hand, I'll just show you real quick. I think the way that I did it was I rearranged this and I said h is equal to 18 over x. So I just plugged that in, then substituted it into the first equation. 1x canceled out, 18x equals 54, x equals 3, and then you just plug that back in up here. 18 divided by 3 equals 6, height equals 6. So it's not that much longer than doing it Desmos, but that is just how you would do it by hand. Solve one of the equations for x or h, and then substitute that into the other equation. Then you can solve for x or h, and then plug that back in, to the first equation. All right, let's look next at the consecutive odd integer problem. So this was a very common one that was posted about a lot immediately after the test happened. So the thing is, with most of the posts about it, it described the two things as being equal, but I saw that there's one or a couple other places where it talked about having wording like at most. So I think the actual correct problem or solution to this, when you set it up, is an inequality, not an actual equation. Because if you do an equation, it'll come out to an exact number, and if that number is not an odd integer, then it doesn't really make sense because you're looking for the exact value that makes both sides equal. But if it's an inequality, I mean, there are multiple values, that would make that equal, but that's why it's asking for, the maximum value, largest value. So the 4 consecutive odd integers are just going to be x, x plus 2, x plus 4, and x plus 6. The reason is because you think about odd integers, 1, 3, 5, 7. It's not the answer, but, they're separated by 2. So that's why it's plus 2, plus 4, plus 6. All right. So now the product of the first integer and 36, so x times 36, okay, is at most, that means it has to be less than or equal to, because we're talking about a maximum. Think about at most, the maximum value you can get. 66 less than, so this means we're subtracting 66 from something. This less than is not an inequality symbol. This is indicating subtraction. Okay, the sum of, so we're adding two things together, first integer and fourth integer. That would be x plus 6. So now, if you go through, just 36x on the left side, 2x, 6 minus 66 minus 60. You can just solve this. 36x less than or equal to negative 60. X is less than or equal to, again, solving this you could also do in Desmos, negative 1.76. So that means the first integer must be less than negative 1.76. And it has to be an odd integer. So it's not negative 2. The first number you come to that's an odd integer, which is less than this, is going to be basically negative 3. So it would be, negative 3, negative 1, 1, and 3. This would be, in other words, this is the maximum value that x could be. Also, I will let you know of a similar problem to this, like a similar, wording that I saw. And basically, let me just look at my notes here. The way that this one was worded is it basically said 37 times the third integer, and I'm assuming here it would have the same at most, 68 less than the sum of the first and fourth integers. So it had the same x plus 6 on the right, and then minus 68 instead of minus 66. Okay. And so then this one you could go ahead and still solve it, same way. It's just going to be slightly different. Actually, 37 times 4, I don't know what that is. So I'm just going to skip the step and go to my notes here. Basically, you end up, this is 2x. So this is 37x plus, what's 30? I guess we'll go to Desmos. 37 times 4 is going to be 150 something. 148. And then you subtract 2x and you get 35x. And then you subtract, this is negative 62. And then when you subtract 148, it becomes negative 210. So you get x is less than or equal to negative 6. So that means the first integer would have to be negative 7. So in this case, it'd be negative 7, negative 5, negative 3, negative 1. But the maximum value that the first integer could be, which is the smallest or least of the 4 integers, would be negative 7. So this was just, and the wording for this, it said like the product of 37 and the third integer, is at most 68 less than the sum of the first and the fourth integer. So that was just basically a different variation of the same problem. All right, let's talk next about problem 5, parallelograms. So you have two parallelograms. One is bigger than the other, ABCD, its area is equal to 31. And then EFGH, its sides are double that, for ABCD. So the short, quick, easy way to get the answer to this for the area of the larger one is just to recognize if the sides are doubles, then that means the scale factor is basically 2. In other words, you multiply by times 2 to get from one side small to one side big. The area factor is basically the scale factor squared because area is 2 dimensions. Scale factor is 1 dimensional, area factor is 2 dimensions. So you have to multiply by it twice or square it. Therefore, the area of the large one will just be 31 times 4, which would be, where is it here? 124. So the correct answer is just going to be 124. Now, alternate way you could do this is just pick some numbers. So first, technically for parallelogram, the area is the base times the height, which is the perpendicular distance between opposite sides. It's not, two of the sides multiplied. But I'm just going to use for my example a rectangle because a rectangle is a parallelogram, by definition. So if I have a rectangle, which is also a parallelogram, meets the same, say it's like 1 and 31 for its two side lengths. The larger one, the sides are double, so this would be 2 and this would be 62. So what's the area of the large one? 2 times 62, 124, I get the same answer. That's just the strategy of picking numbers. Let's look at number 6 next. Basically, you were told, you're given inequality, told this represents the solution to ax minus blah, 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 blah. Find the greatest value of a. So essentially, what you're going to do here is we're going to just take this inequality and solve it, add 21 to both sides, ax less than or equal to 45, divide by a. So the solution to this inequality is x is less than or equal to 45 over a. But we also know that x is greater than or equal to 9 also represents the solution. So essentially what you're doing is you're figuring out what is the value of a to transform this into x is greater than or equal to negative 9. So, okay, what does a have to be in order to make 45 divided by it equal negative 9? Well, 45 divided by a equals negative 9. Just cross multiply 45, negative 9a, divided by negative 9. A has to be negative 5. So, if you plug negative 5 in for a, now you get negative 9 on the right. That checks. Notice the inequality sign also flips because you're dividing by negative number. So that checks. So now we found a value for a, and it gives us the correct solution to the inequality. So that's going to be the correct answer. Correct answer is going to be just negative 5. Now we can also confirm this in Desmos. So basically, we're going to graph this inequality, and then going to graph the other one. We'll add a slider for a, and if you notice here, like it's going kind of the wrong direction. We want the two things to completely overlap, essentially. Excuse me. And notice here, oops, went too far. Right here, they completely overlap. When I plug in -5 for A, notice the solution sets are identical. Okay, you know, if I unhighlight this, I have this. If I unhighlight this, I have the gray. So that's what we're looking for. So that just confirms we have the correct answer. All right, next question, number 7. Here's one that deals with density and the cube. So you have this cube. All right, you're given the density, 0.26. The edge length of the cube is just, I don't know why. Supposedly they gave it as 3.000 centimeters. I don't know why they did this. I mean, you know, it's just 3 right here. So hopefully you know the equation. Density is mass divided by volume. If you didn't know that, you can look at the units and hopefully recognize grams as a mass and cubic centimeters as a volume. So we know the density. We don't know the mass. That's what we're finding. The volume, well, length times width times height. 3 times 3 times 3, 27. And now the mass is just going to be 27 times 0.26. Correct answer is just going to be 7.02 grams. So 7.02 is either what you'd select some multiple choice answer or just, you know, fill in to the question. All right. Let's look at the next question now, number 8. Here you're given, I don't know why that's not a plus there. I'll fix that on the actual downloadable worksheet, but that's just supposed to be plus C right here. So you're given a quadratic equation and you're told it has this solution and they want to know what's the value of C. So basically, if you notice, you start plugging things into the quadratic formula here. So this is A, right? This is B, this is C. So notice things pretty much match up. You know, in the bottom it's 2A, so 2 times 12 is 24, so that matches. So all we're really doing is we're saying like 544 is equal to B squared minus 4AC. Now B is 4, so B squared is just going to be 16. A is 12. 4 times 12 is 48. So now you just go ahead and solve this equation. Again, this could be done in Desmos, but you know, whatever. I'll probably just go ahead and do it by hand. So you get 528 equals negative 48C, divided by negative 48, divided by negative 48. C has to equal 11. Now we could just check this in Desmos. So all I'm going to do is type in the problem and use X instead of Y, or instead of W, excuse me. All right, so now I have two solutions here. 0.805, negative 1.138. So let's see if when I type in the solution we're given, okay, so notice I get 0.8051, blah, blah, blah. Not that one. Yes, it does correspond to the one on the right, 0.805. So it matches or checks, and it tells me that this should be negative 11 right here. Not positive. Negative 11 is the correct value for C. All right, next up is a tricky problem dealing again with area factor and scale factor. So on this problem, you're told about two cubes, okay? One of them has an edge length that is 88/7 times the edge length of the other one. So, but then they tell you that the surface area of the smaller cube is basically equal to W times surface area of the larger one. Find W. Okay, so there's multiple ways you could do this. First way I'll show you is kind of the theoretical way, and then I'll show you how you could do it, you know, the actual example out with picking numbers. Okay. X, Y, X, my two cubes. Okay. So for cube Y, so the scale factor basically is 88/7 to get from cube Y to cube X. You know, cube Y is smaller, cube X is bigger. Just right here, small, big. Okay. So the surface area of cube Y, okay, compared to the surface area of cube X, essentially, you know, to get from the surface area of the small to the big, you would have to multiply by the area factor, which is the scale factor squared. Okay, so again, the area factor here would be 88/7 squared, because we're talking about an area factor. We're talking about surface area. Area is two-dimensional, so in other words, if the area of the bottom cube is 1, just say, then to get the area of the large cube of X, you would multiply by 88/7 squared, 1 times that. So just confirm, this is like the small area times the area factor, which is just the scale factor squared, equals, the large area. But now they tell us surface area y is equal to w times surface area x. So you have to basically what you have to do is get this 88/7 squared over to the other side, because they want surface area y alone, and they want to know what the w is, the number is that's multiplied by the surface area of x. So essentially what you're going to do is you could divide by 88/7 squared, or really what you're doing is you're going to multiply by 7/88 squared. So the surface area of y is equal to 7/88 squared surface area of x. So now this is the number that corresponds to the w. So the w value is going to be 7 squared over 88 squared, which is 49 over, just make sure I get this right, 46464. 49,46464. Just confirm that in Desmos. No, not the right number. I had an extra 6 in that. Never mind. Sorry. It should be 7694. No. 7744. I'm looking at the work for the example I did using picking numbers, where I actually multiplied the things out by 6. So now, because this is too big, if this was a grid in, thing, too big to fill in. If it was a multiple choice, obviously you'd look for this fraction and select it. But if it was an actual student produced response you could fill in, well, you just have to go to Desmos and just divide 49 by 7744, and so you could either fill in 0.0063 as the decimal, or you could do 0.006. That would, either of those would fill up all 5 spaces. Okay, so this is the theoretical explanation behind it. Now what I'm going to do is I'm going to actually do it out picking some numbers and just showing you, using actual numbers how it works out. So let's say cube y has sides 1, 1, and 1. Okay, therefore the surface area for y is going to be 1 times 1, the area of one face, and then just times 6, because they're all equal, because it's a cube. Okay, so total surface area for y is going to be 6. It means the sides in cube y are all going to be 88/7. 88/7, but 88/7. So the surface area of x is just basically 88/7 times 88/7, and then times 6. So if you multiply this whole thing out, it turns out to be 46464 all over 49. So now you can basically go set up the equation. Surface area of y equals w times surface area of x. And now you just solve this for w. So you're just going to basically multiply by the reciprocal here, 49 on top, 46464. Do the same thing over here, times 49 over 46464. And that's going to give us our value for w. So notice if we go back to Desmos here, as we got 49 on top, 46464, okay? And that's being multiplied by 6. So that is our value for w. Notice we get the exact same answer that I had above. Or if you want to just confirm in the fraction form, notice again, it's the 49/7744. Okay, so decimal form, fraction form, but we get the same answer. It's just here I'm technically plugging in actual values for the surface area of x and y and then solving for x, or for w, excuse me, based on those values. So we get the same, basically the same answer. All right, next one. This is a problem that had like basically a large triangle and then a bunch of lines and different angles in it. And uh, most of the information was provided for it, but the one thing that I did add to this, because I think you do need to know this, is that DE and AC are parallel. I don't think there's any way to prove just from everything else, but you basically know in the picture that um, OA and OB are equal, and you know that these two sides here, AB and AC are equal. And you also know that this angle is equal to 30 degrees. And you know AB, this side over here, is 58. What's the length of BE? So basically what ends up happening here is this overall triangle ends up being split into two congruent triangles on the left, ABF and CBF. So that means all the angles and sides and everything are going to be equal. So technically, like, we can find the length of BD, and then we can just set, and then basically BE is going to be the same as that. So here's what we know. And another reason you have to know DE is parallel to AC is that if this angle is 30, then this angle right here is 30. Okay. These will also be perpendicular because up here B is equidistant from the endpoints of this line segment AC. That's why AB and AC are the same. Therefore, B will be on the perpendicular bisector of segment AC. So that's how I know that it's going to be perpendicular to this right here. And then because DE and AC are parallel, well, this is corresponding angle. This is also a right angle. Okay. So then what happens is basically, notice this whole angle becomes 120. So now what you do is you split this up like this whole large triangle into two triangles, and the two triangles end up being congruent here. And the reason is because you have a pair of angles here, you have a pair of angles here, you have two right angles, and then you have one pair of congruent sides right here that's shared. So AAS. So these two triangles, let me just pick a different color here. So basically this triangle here and this triangle here will be congruent to each other. So let me just highlight, let me just kind of separate out here. So we know also the following. Because this whole side is 58, if I make two congruent triangles, that means that A to this point, I don't know what, we'll just call this point P. For AP to BP, these two sides have to be the same because the two triangles are congruent. So that means it's going to be split up here 29 and 29. Okay? So therefore, this is going to be 29. This is A, this is point P, this is O. I also know, let's see here. Oh, you also know that because this whole angle is 120, okay? If you subtract that from 180, you get 60. And then this angle at the top and this angle down here at the bottom will be congruent. Because if you look at the overall large triangle AOB, these two, let me just pick a different color. Let me use red here. These two red angles are across from congruent sides because they're across from OB and OA, which are congruent. Therefore, the 60 gets cut in half, and they are each 30. So this is also 30, and this is also 30. So that means down here, I know this is 30. Therefore, I know this also has to be 60. So what that allows me to find now is I have right here this side's across from the 60, so this is the long leg. And again, you could do this using trig if you wanted to. I'm just using the 30, 60, 90 kind of shortcuts. So to get from the long leg to the short leg over here across from the 30, I'm just going to do 29 divided by root 3. And then to get from the short leg to the hypotenuse, I'm going to multiply this by 2. So this is going to be 58 square root 3. Now, or 58, excuse me, divided by root 3. And now you could also rationalize this by just doing times root 3 over root 3. So really it's 58 root 3 over 3. Okay, that's for OA here. Now, therefore, because again, these two triangles are congruent, the two green ones, that means that OB is also equal to 58 root 3 over 3. So right here, 58 root 3 over 3 for OB. So now what you can do is you can, let me see which triangle I looked at here. I know 58 root, okay. So now you can just look at either of these two top triangles. So like, let's say we look at the one on the right. Or actually, let me look at the one on the left, and then, like I said, I know that because it makes two congruent triangles. So we have B up here, we have O here, and then here we have D. So this is 58 root 3 over 3. I know this angle is 30 degrees, therefore this angle has to be 60 degrees. So this is across from a 60-degree angle, so this is the long leg. To get the short leg using the 30-60-90 triangle right triangle properties, I have to take this and I have to divide it by root 3. What's going to happen is the root 3's are going to cancel, and I'm going to get 58 over 3 for this side, for DO, right here. That's the short leg. To get to the hypotenuse now, I multiply it by 2, 116 over 3. That's going to be the final answer because, again, basically you have two congruent triangles up here, BOD, BOE. Again, because the whole thing is split basically down the middle, into two congruent triangles. Essentially, because they're both right triangles, and you can use HL, hypotenuse leg. You have the right angles here, you have the shared leg, BF, reflexive property. It's the same in both, and then you're told AB and AC are congruent. So that's how we know the two overall are congruent, and therefore that would lead to these two small here also being congruent. So BD is going to be the same as BE. Therefore, this is the correct answer. It's 116 over 3. You could also, if you had to grid this in, you could also put 38.66. You could also put 38.67 if you round it. First one is truncating it. This is a long problem. This is a complicated problem. Maybe there's more information that it's given. The students didn't remember, and therefore makes it a little easier, shorter, quicker to do. But just based on what was provided and what I think that you were given, this is how you would solve this problem out. All right, the last question here, we have basically a dot plot. This is data set A. And now you're going to make a new data set B, by increasing every value here by 32. So, all of these just plus 32 all the way across. So which of the following values in D will change compared to data set A? So the mean or the average is obviously going to increase. Here the mean is some number between 20 and 25, but now it's going to be some number between 52 and 57. So the mean is obviously going to increase. The median is also going to increase. Again, the median is something between 20 and 25, and now it's going to be again between 52 and 57. So those two for sure. What about the standard deviation and the range? So the range is just the difference between the top, highest, and lowest values. So here that's just 5. And if you increase every number by the same amount, the range is going to still stay 5. So that will not increase, not change. And the standard deviation is also not going to change as well, because the standard deviation is like, how are the values split up with respect to the mean? So when you increase everything by 32, it's going to be the exact same pattern. It's just that the number here is now going to be 52 and 53 and 54 and 55 and 56 and 57. But the way that it's distributed relative to the mean, which is essentially what standard deviation tells you, will not change. So therefore, correct answer to this one is going to be B. The mean and the median will change. Standard deviation will not change. Range will not change. Okay, I hope you enjoyed this problem set. 11 more problems from the October 2024 Digital SAT Math section. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications below. If you have any questions or comments or alternate solution methods, please do leave them in the comments below. Otherwise, check out the video for part 1, which had 11 problems on it. Also, check out the video for part 2, which had 11 problems on it as well. This is part 3, so now we've got 33 total problems, again, from the October 2024 Digital SAT exam. For those who see this before the November test, good luck on that. Or I guess before even, before the December test as well. Good luck on that exam. Otherwise, I'll be back soon with more math-related content.